Now we are going for chapter 6.3 that is talking about t-distribution, student t-distribution. Most cases, if we don't know the population mean and we want to know the estimate the population mean, most in cases we don't know the variance of the population. So actually this t-distribution is more realized distribution to solve those kind of questions. T-distribution has looks like very similar with the normal distribution and standard normal distribution. So mean is 0 and symmetrical about the mean, but this is a little bit different. That it has a thicker the tails than the standard normal distribution. But if the degree of freedom, that is the sample size getting bigger and bigger, that is very close to the standard normal distribution. So someone already calculated the probability for that the t-distribution when the degree of freedom is different. That is a table E. So we can just try to find the number of any specific confidence level with the degree of freedom that t-distribution can have. That is n-1, the actual sample size minus 1. So example 6.3.1 is about the variable, the isometric gastrosolus muscle strength. And point estimator for population mean is x bar, right? We are trying to guess what is the population mean, okay, with some confidence level. And we got the x bar, that is 250.8, that was measured from the sample. In here, there are no information given that the population is normally distributed. And if you don't have any more information and the sample size, that kind of thing, you can stop here, okay? And even that question gave you 19 patients only. So sample size is smaller than 30, so we cannot use central limit theorem in here. So if you see this kind of case in the real or in the exam, you stop there and then say, well, we need more information. We need to get more sample. But in here, to solve this question, the authors assume normal distribution. So we just follow that assumption. So X is normally distributed, and standard mu is mu, we are trying to estimate, and then standard deviation is a standard deviation. X bar follows the normal distribution because the population is normal distribution, right? And then sample mean should be same with the population mean, and the standard deviation is like before, population standard deviation divided by square root of the sample size. And this, right now, we don't know mean and standard deviation of the sample mean, so we have to use t-distribution. This x bar right now not normal distribution. That one is follow t-distribution. So it should be like this, okay? And then we need the degree of freedom. That is m-1. That is 19 minus 1 in this case. So 18 is the degree of freedom. Anyway, so we use t-distribution that is same thing, estimator, x bar, because we want to estimate mean of the population, plus minus, and we're gonna use that t distribution reliability coefficient in here. That one is a t, and 1 minus alpha over 2